Welcome once again to Forecast Lab for September 11th, 2020. In today's show, we'll take a look at continued wildfire problems and lots of smoke in California and Oregon. A powerful weather system in the high plains of the central U.S. Smoke from the California wildfires moving into West Texas. We'll also take a look at some vigorous sea breeze storms moving westward through the southeast U.S. And then we'll take a look at the tropics, where we have Tropical Storm Paulette, 65-mile-an-hour winds, verging on hurricane strength, and also Tropical Depression 19 moving into Florida this weekend. A good place to start, especially this time of year, is the water vapor imagery. This gives us an idea where the moisture in the middle and upper troposphere is located and gives us an indication of the steering flow. The dominant feature we have is this polar front type feature from Texas into the Midwest. And this is associated with a front that is basically running something like that. It's an antifront, which means a lot of the lift is concentrated behind the surface front. And then out to the west, there's an occlusion. You can see how wrapped up that is, and we have this dry slot working into the south side. In Arizona, we have this interesting little wave. This is probably either a jet max or a shortwave trough. And then in the southeast U.S., we have the typical tropical activity. This is going to be associated with some combination of a sea breeze, an easterly wave, and or the tropical disturbance down southeast of Florida. The 500 millibar heights and vorticity shows that occlusion in the high plains is the dominant feature, and it's detached from the prevailing westerlies, which are up in Canada, and that's where we find the primary jet max activity. It's sort of a split flow. We have the main polar front way up there in the Canadian prairies to Quebec and Ontario, and then it splits off into Utah, the Four Corners, and the Midwest, kind of like that. Most likely this low is on its way out, and we should see it move across the Great Lakes over the next couple days, and that'll mean the ridge on the west coast should start to move in and take over more of the western U.S. Still not a very good idea what's going on there in Arizona. That could be a little region of moisture just advecting through the flow. I don't see much in the way of dynamic lift working across that area. The 500 millibar omega, the vertical velocity, does show kind of a loose area of upward motion. So if we want to actually track that back, the best thing to do is go to the satellite and work backwards. The infrared satellite imagery 2 days ago shows this little area of mid-level lift, and we can watch as that moves into the eastern California deserts and then into Arizona today. And there's what that region of moisture and lift looked like 2 days ago, and we see that moving southeast into Arizona like that. And that's likely co-located with a lot of that smoke coming from California. There's what the weather map looks like early this evening. The cold air mass that came through earlier in the week covers this huge area. However, it is basically baking and roasting underneath the September sun in this part of the country. So we're getting very rapid air mass modification, temperatures gradually coming up. Only 69 at Albuquerque, but already up to 88 there at Tucson and 89 at Phoenix. The air mass is still a little bit cool there in the Intermountain region, but rapidly heating up into the upper 80s out there around Reno and Winnemucca, and we're back up to hot temperatures in the north part of the San Joaquin Valley. The satellite looking like this with the smoke on its way westward. In Colorado, we see some evidence of that snow, some of the peaks there covered by snow. Some of this is also mountain wave activity. The best way to distinguish that is by zooming in. Now, you can tell the mountain wave activity because it's going to move very slightly. You can see these bands right there. They're perpendicular to the mean flow. And that's basically stratocumulus and altocumulus cloud The white spots that are not moving at all, that's going to be snow cover on the higher terrain. So it looks like we've eroded pretty much all the snow in Denver and Colorado Springs, even around South Park and up to Breckenridge. Not much snow showing, so it looks like it's up above the 10,000-foot line this afternoon. And up to the north, we see some cold air coming in. This is close to that upper level low, so the air mass is going to be fairly unstable in that region. And we can see that with a skew-t profile. This is going to be valid for about right now around Cheyenne. So I'm going to take a quick check to the left side. There's no high omegas, so that means that we're not picking up a convective cell and corrupting the sounding. So all of this data should be pretty much valid. And what we see here is a classic inverted V, cool dry air in the low levels, and in the mid levels, quite a bit of moisture, and just enough of a lapse rate to get some convective cloud growth in there. There's how things look in the Pacific Northwest this evening. You can see there's just been a massive air mass recovery in Saskatchewan, Alberta, and Montana. Temperatures all the way up into the mid-80s. And we've even got 90s around Omak and some of those stations in southern British Columbia. I'm racking my brain for towns, and I just don't know them very well. But the next front is on its way south, and the warm front is pushing eastward, and I could not help drawing this awkward frontal system in there. Looks like the cold front and warm front are backwards, but I had to give that a try because the warm air mass is definitely up to the north, and down to the south you can see 60s. So yeah, that's actually valid, and I think this actually connects back up to the other tail end of the frontal system in Nevada. Down there in Nebraska and South Dakota, we can see the main upper level low there. That's the occlusion, and that's going to be a cold core barotropic system. The frontal system in Saskatchewan and Manitoba, that's obviously pretty dry. And then we've got some of the smoke trying to make it back eastward. It got shoved to the west when all that cold air blasted through that region and went offshore, but now it's coming back in. So you're seeing these weird little circulations in Oregon. Other than that, it is pretty quiet, and a lot of the cloud material heading for the Great Lakes as that cutoff low moves eastward. Things are obviously going to go downhill in the Great Lakes area. Got the approach of the so-called baroclinic leaf that's coming in from Missouri and Iowa, and that's associated with a large area of warm and moist air advection coming in from the south. We've got some flat-looking clouds there in Indiana and Ohio. That's sort of suggestive to me that that's post-frontal stratocumulus. You normally don't see that kind of stratification out ahead of a polar front. So there's a good chance that we're going to find the front somewhere in this area. I've not analyzed it yet, but that's where I would be looking. And then down there in Virginia and the Carolinas, we have some vertical cumulus. There's some towers and CBs. So that's going to be in the tropical air. And let's just check out the surface map and see what's going on. There's our weather map in the northeastern U.S. High pressure centered in southeast Ontario there, and that means northerly flow pushing into Ohio and Illinois. So indeed, that has kicked the front southward. And since our isobars run roughly like that, if we turn the flow so that it's southerly in advance of the next system to where the 850 flow, 700 flow comes out of the southeast or the south, that's going to mean lift. And especially if we have humid conditions like we can see with this marginal VFR, these low ceiling stratocumulus down in Ohio, Indiana, and Illinois. Since those clouds are already there, that means the relative humidity is high, and that means that that cloud mass will probably grow into an overcast layer and start precipitating. So this is kind of like the beginning stages of isentropic lift coming together. And I do see evidence of an occluded front. There it is right there. This is detached from the main warm air down to the south, and you can see a pretty good contrast in wind flow and weather conditions. Kind of resembles a warm front a little bit. You can see that grungy, low overcast out ahead of it. And that makes sense. We can see the colder temperatures are out ahead of it, which means the air mass to the south will lift over that cooler air, and that front will act more like a warm front. I realized I hosed up that front because look at that 87 there at St. Louis. That warm sector is kind of pulling up like a wedge there. See that right there? What that means is we have to redraw the fronts. And that also means that our triple point, our main baroclinic development area, is right there north of St. Louis. So let's put in that front. That ain't our front. That was our old one. Let's redo that. Okay, our cold front is going to come something like that right there. I'm going mostly by the temperature indications. You don't want to focus too much on the wind direction. And we'll draw in our warm front. That's obviously north of St. Louis. And we can see it's definitely in between these two stations here. And because the wind flow is from northeast to southwest, I think that is going to be acting a little bit like a cold front. So I'm going to switch over to a cold front signature. And I'll start drawing that in Virginia and then bring it over. Looks like a little bit of cold air damming there. You can see it's probably north of Nashville. And then that connects back into our front, kind of like that. So that's our analysis. And what about the occluded front? Well, this is going to be acting more like a warm front, so let me fix that. And I'm going to draw it a little bit more like a warm occlusion and bring it kind of like that. Now, there's probably a low in there, a little baroclinic low, so I'm going to put it in there. There you go. Poor little low, not being recognized by the objective analysis plot, but I drew it in there anyway. It's probably there. You can see the cyclonic circulation there in northern Missouri. And then I drew in our little thunderstorm sea breeze signature, and that goes mostly off of the satellite indications. Let's take a look at that satellite. There it is. There's that line of storms. Yeah, that's a pretty wide area, so that's going to be associated with unstable, uncapped air and a sea breeze, and probably a few boundaries here and there throughout the southeast U.S. A lot of those thunderstorms all the way back into Mississippi, and I would say there's a good bet the precipitable waters are pretty high in that part of the country. Yep, there it is. You can see a vast area of 2 to 2.5 inches across the southeastern U.S., and then pulling into that occluded system, a plume of 1.5 to 2 inch precipitable water amounts. So that kind of thing will be conducive to thunderstorms and showers in Illinois if we have the instability. And that's a forecast sounding there near the St. Louis area. Looks conditionally unstable, not particularly favorable for showers and thunderstorms. But that's a very moist column. Precipitable waters there running almost 2 inches. So if you can get a source of lift there from those frontal boundaries, the air mass being uncapped, yeah, that's probably going to be favoring some heavy rain. And SPC, they've got a general thunderstorm forecast area up the Mississippi River Valley. And WPC looking for some slight potential for heavy rainfall north of St. Louis. And you can see that that's kind of at the nose of that southerly flow in that high precipitable water air. Well, we've used up a lot of time, so let's just take a quick look at NHC. Paulette is expected to take aim on Bermuda there, coming in as a Category 2 hurricane. Renee, also still a tropical storm, but it looks like it's just going to kind of wander around out in the deep Atlantic. And of course, that disturbance coming out of the Cape Verde area, that's taken more of a southerly course, and that has potential impacts for the Caribbean and southwestern Atlantic. Now, yesterday we saw the GFS taking that system and moving it towards the Dominican Republic. But today, as we expected, there's been a considerable change, and we're bringing the storm more into the deep Atlantic and recurving it pretty quickly. That's what the European model had yesterday. We've seen some very good skill with the European model. And you can see the European model right there pretty much keeping to that same scenario. So we're not really expecting any impacts in the Caribbean or the Gulf of Mexico or the southeastern U.S. at this time, but things, of course, could change. So just check back next week and we'll take a look. And that's about all I got for this edition of Forecast Lab. Hope you all have a great weekend. Take care, and we will see you next week. Bye-bye.